Let's look at this episode of Modern Maths Bites. 80% of people surveyed satisfied at least one of the four conditions being surveyed. 65% satisfied at least two of the four conditions, and 40% satisfied at least three of the four conditions. What percentage of those surveyed satisfy exactly two of the four conditions being surveyed? Okay, so I'm saying exactly one plus exactly two plus exactly three plus exactly 4 is equal to 80. This is told to us. And then 65% satisfied at least 2. So this entire range here, this is 65, which tells me exactly 1 was satisfied by 15% of the people. And 40% satisfied at least 3 of the 4. So these two add up to 40. If these two add up to 40, then exactly 2 has to necessarily be 25%. And finally, we are only asked this: what percentage of those surveyed satisfied exactly two of the four conditions being surveyed? Answer has to be option A, 25%. Next, using each of 0, 1, 1, 2, 2, 2 exactly once, how many 6-digit numbers can be formed? Now, if I'm trying to form a 6-digit number, the leading digit cannot be 0. So it will be 1 followed by 5 digits. And which are the 5 digits available? 0, 1, 2, 2, 2. This is available. 2, 2, 2 because this is same. The number of cases will be 5 factorial by 3 factorial, which is equal to 20. The other case would be 2 followed by 5 blanks. And this time, once 2 is taken out, I'm left with 2 2s and 2 1s. So it will be 5 factorial by 2 factorial, 2 factorial, which is equal to 30. Altogether, I will get 50 cases. So option B. Next, 8 people are to be seated in a rectangular table. 8 people are to be seated in a rectangular table with 4 people being seated along each of the longer 2 edges of the table. So a rectangular table 1, 2, 3, 4. 1, 2, 3, 4. Okay. If the 4 chairs along one edge are white colored, so let's say these 4 are white colored, and along the other edge are black colored. So these 4 are black colored. Find the number of ways in which 8 people can be seated. Okay, now the first person who walks in, when he looks at these seats, for him, all the seats are distinct because this is a white seat. This is a white seat. Why is this not working? Excuse me. This is a white seat which has the corner on its right. This is a white seat which has corner on its left. This is a white seat which has corner on its left, one seat away. This is a white seat that has corner one seat right away. So all these seats are distinct. The first person has 8 ways of selecting his seat. And now after the first person is seated, the remaining 7 people have 7 factorial ways of selecting their seats. Or altogether, the correct answer here will be A, because all the 8 seats are distinct. Okay, next. An urn has 3 white and 3 black hats. A person draws 2n number of hats from amongst these hats and takes them with him. What is the probability that the urn still has equal number of white and black hats? I'm interpreting this question as, if I'm looking for probability that the urn still has equal number of white and black hats, the person has taken away equal number of white and black hats. If initially the number of white and black hats are identical, the person has taken with him also equal number of white and black hats. Assume n lies in the range 0 to 3 and n is a natural number. So n can only take values 1 or 2. And each value of n is equally likely to be drawn. So there is a 50% chance that n is equal to 1. There is a 50% chance that n is equal to 2. Okay, when n is equal to 1, can you see it will be either black-white or white-black? The order in which the hats are being taken out, it will be this. So the probability in this case will be half into 3 by 6 into 3 by 5. And because all that is changing is the order, in order to get the full setup here, I need to multiply this by 2. So now I get this and this cancelled, this and this cancelled, or the probability in this case is 3 by 10. Now working with when n is equal to 2, n is equal to 2, I will take out black, black, white, white, and these can be rearranged in how many ways? 4 factorial by 2 factorial, 2 factorial, or 6 ways. This can happen in 6 ways, the order in which the caps are taken out. So this is done in, let's say 6 into half the probability of n being equal to 2 into 3 by 6 into 2 by 5 into 3 by 4 into 2 by 3. Okay. So 6 and 6 gone, 4 gone, 2 and 2 gone, 3 gone, 3 gone. So I'm left with 3 by 10 all over again. Even in this case, I'm getting 3 by 10. So 3 by 10 plus 3 by 10. Altogether, I will get 6 by 10, which is as good as 3 by 5. So correct answer to this question is option D, 3 by 5. Next, 5 soldiers are standing in line shoulder to shoulder. 2 soldiers are to be selected from them such that no 2 neighbors are selected. In how many ways can this be done? Because this is a very small number, I will count it very slowly and show you. The pairs that are possible are AC, AD, AE, BD, BE, or CE. These are the pairs that can be counted. Now, logically, if you want to do it in a mathematical or formulaic way, what you can look at is, see, out of these 5 people, 2 have to be selected. After the first person that is selected, whichever that first person is, the second person, the person right after that is blocked. So can I say, because of that blocking, I'm left with 4 people. And out of those 4, I have to select 2 people. 4C2, this is equal to 6. Either you count it slowly, you get to 6, or you do it logically, you will get to 6. Why I've talked of the logical ways, because let's say if there were 15 soldiers and you had to select 3 people, at that time it is not expected you would be making cases like this. So at that time, what would be useful is, out of 15 people, if 2 are blocked, because after the first person 1 person is blocked, after the second person 1 person is blocked, 2 people are blocked, you need 3 people, so it will be 13C3 in that case. You have 15 people and you have to identify 3 people who are not right next to each other. So that is how you should solve it. Hopefully you learned something. That will be all. Okay, bye.